In this example, we're asked to evaluate a second derivative. So what we're going to need to do is we need to find the first derivative, the second derivative, and once we get it, substitute the value of x equal -2 in for x. A nice trick if you have a constant in the numerator is to begin by writing the denominator to the power of -1, rather than try to use the quotient rule. And this will let us use the general chain rule, giving us the derivative of -2, 1 minus x to the -2, exponent down, subtract 1, times the derivative of the part inside, which is the derivative is -1. We can simplify that first. Negative and negative is positive. 1 minus x to the -2. So there's the first derivative. The second derivative, we just do it again. So the -2 comes down, gives -4. 1 minus x to the -3 times the derivative of the part in brackets. And that's again -1. Giving us a second derivative of 4 over 1 minus x all cubed. Now we know x is -2 for the value we want. So the second derivative of -2 is 4 over 1 minus -2 cubed, which is 4 over 27. And so that's the value of the second derivative at x equals -2. In this example, we're asked to find the second derivative, or y double prime, for the implicit function here. So we'll find the first derivative. So the derivative of this is 4x plus 6y times y prime. Remember, this is a chain rule. 6y, 2 minus 1 is 1. So that's why it's 6y. Times the derivative of the part that didn't change. In this case, it's the derivative of y, which is y prime. That equals 0. Easiest thing to do is to solve this for y prime. So that gives us -4x over 6y, or -2x over 3y. That's the first derivative. Now we need the second derivative. Well, the derivative of y prime is y double prime, and that equals, here we have a quotient now, so we need to use the quotient rule. Derivative of the top, it's going to be -2, keep the bottom, minus keep the top, derivative of the bottom. So the derivative of 3y is 3y prime all over the denominator squared, so 3y all squared. So there's the second derivative. Since we know the first derivative is this, we can substitute that in for this one, and we'll do that, giving us -6y plus negative with negative 6x times, for y prime we're going to do this, so it's -2x over 3y all over 9y squared. And we can do more simplification, but for our purposes this will be enough right now. The second derivative is this with respect to x and y.